Welcome to this explainer. Okay, today we're diving into a real game theory detective story playing out at the absolute bleeding edge of tech. We're looking at how the world's top artificial intelligence rankings, the very leaderboards that tell us which AI models are the best, are being silently manipulated. It's a crazy story of statistics, strategy, and a really clever exploit hiding right in plain sight.
So, how exactly do you hack an AI leaderboard? You'd probably think it takes breaking into a server or altering vote tallies, but MIT researchers found something way more subtle. They realized that seemingly identical or even slightly inferior AI models are mysteriously climbing the ranks on highly trusted evaluation platforms. And they aren't doing it by being smarter. They're doing it through a mathematical loophole.
All right, Section 1, the AI leaderboard boom, the high-stakes battleground. To get how this hack actually works, we gotta talk about generative AI arenas. Think of platforms like Chatbot Arena. Basically, you type in a prompt, two anonymous AI models spit out answers side by side, and you vote on the winner. It's literally a blind taste test. Behind the scenes, these platforms use a statistical method called the Bradley-Terry model. Sounds complicated, but it just takes all those chaotic, organic human votes and magically turns them into a neat, competitive leaderboard.
And look, this is absolutely not just for bragging rights. The stakes here are massive. Hitting that #1 spot, even for just a week, is a huge economic signal. We are talking about rankings that dictate corporate valuations, steer billions with a B in venture capital, and tell millions of developers which tools they should be using. But whenever a metric becomes a target, people try to game it. That brings us to Section 2, gaming the system, the vulnerability of noise. Think about this for a second. At the very top of these leaderboards, the margins are incredibly razor thin. Like the #1 ranked AI model might only beat the 20th ranked model about 58% of the time. 58%! And since these rankings rely on a relatively small number of human votes per matchup, well, that introduces statistical noise. And where there's noise, there is an exploit waiting to happen.
Which leads to the MIT researchers' big discovery. Section 3, the clone cheat code, strategic candidacy.
Okay, here's the cheat code. If you're an AI developer, you can literally just submit multiple identical or nearly identical copies of your model to the arena. Why? Because of what the researchers call the lottery ticket effect. Because of that statistical noise we just talked about, every clone you submit is essentially buying an extra lottery ticket. One of those clones is bound to get lucky with its random matchups and score an artificially high rank. Your company gets rewarded for its highest-ranking model, so you don't care if Clone A completely tanks and finishes 15th, as long as Clone B randomly spikes to 3rd. There's also this secondary thing called the new competitor effect, where flooding the arena shifts the win rates of everyone else. But that lottery ticket effect, that is the real driver here.
And you can see the reality of this exploit right here. Under the current status quo system, just tossing in a single clone drastically inflates a model's rank. This is especially true in specialized arenas, like coding or expert boards, because they just have fewer votes. Fewer votes means way more noise, which basically supercharges this clone cheat code. Models are jumping up multiple ranks for free, literally just by entering a twin into the race. Crazy, right?
Obviously, if anyone can just buy their way to the top with clones, the whole leaderboard loses its credibility. So, Section 4, the you rank, we rank solution, patching the exploit. The MIT researchers didn't just point out the flaw, they actually designed a remarkably elegant, kinda counterintuitive patch. On one side, you have the broken status quo, completely vulnerable to noise and rewarding clones. On the other side is their fix, the you rank, we rank, or YRWR system. This new mechanism makes the leaderboard mathematically ungameable. It neutralizes that lottery ticket effect entirely. And get this, it does it without the platform needing to magically know which models are clones.
So how does YRWR actually work? It's beautifully simple. Step 1, the AI producer submits their models, same as always. But step 2 is the twist. The producer must submit their own private ranking of those models. They have to explicitly say, I believe model A is better than model B. Then, in step 3, the mechanism mathematically corrects the final public scores based on that self-reported ranking. Now, the real secret sauce here is the score correction rule. Under YRWR, a model's corrected score is capped at the minimum estimated score among all the models the producer ranked ahead of it. Why is that so brilliant? Well, think about it. If you submit two clones, you have to rank one over the other. Say you put clone 1 above clone 2. If clone 2 gets super lucky with the voting noise and gets a huge score, the system automatically forces that score back down to whatever your top clone got. Actually, scratch that. It forces it to the minimum score of the clones ranked above it. You just can't harvest that lucky maximum score anymore. It mathematically destroys the value of buying extra lottery tickets.
Sounds great in theory, but does it actually hold up? Let's look at Section 5, Proof in the Data, the exploit patched. The before and after here is just striking. Under the status quo, you see these massive peaks of artificial rank improvements across the board. But when you run that exact same data through the U-rank, we-rank mechanism, those gains completely flatline. I mean, even if a producer spams the system with 5 clones, their rank improvement hovers essentially at 0. The exploit is entirely shut down.
And when you zoom into specific competitive categories, the impact is undeniable. In the coding or expert arenas under the old system, submitting clones netted these huge leaps in rank. But under U-rank, we-rank, that benefit is absolutely crushed down to 0. You literally cannot cheat the math.
But honestly, here's the best part. YRWR doesn't just stop the cheating, it actually makes the overall leaderboard significantly more accurate, because the mechanism acts like a denoising filter. By leveraging the producer's own knowledge about their models, the final rankings are much closer to the true ground reality than the status quo ever was. It's a total win-win. You stop the hackers and you give everyone better data.
So what's the big takeaway here? As AI becomes an absolutely critical part of our economy and daily lives, how we evaluate these tools matters immensely. We just can't rely on naive systems that get easily tripped up by statistical noise. Designing strategy-proof systems like U-rank, we-rank ensures these leaderboards actually remain a trustworthy, accurate, and fair signal for developers, investors, and us everyday users.
Which leaves us with a pretty provocative thought to wrap up this explainer. AI capabilities are evolving at breakneck speed, right? But evaluation is basically an arms race too. As these models get smarter and the financial incentives to hit #1 grow even larger, are our evaluation methods smart enough to keep up? The U-rank, we-rank mechanism is a brilliant patch, but for sure, the game is really just beginning. Thanks for joining me on this explainer, and keep your eyes on the data.